meetup. This time we brought you two guys, actually, Robin and Javi. So thank you guys for coming. Today we're going to talk about components done right. So hopefully you will do it right. If you get questions during the presentation, please do it after. And if you want to, if you will forget it, so go to slide.do, use the hashtag Prague, and please ask questions then. And then afterwards, we're going to ask guys those questions.
Yeah, it's recording now.
So, anyone familiar with Reactive Conf? Our CAP is coming to Reactive conference. And, okay. And who is planning to come and don't have tickets yet? Me. Actually, these two guys also will come, so if you like the talk, maybe it will persuade you, or if not, maybe our partner will persuade you with something else. So I would like to give a couple of seconds to our partner, without whom we would not be here. So thank you and welcome back in Japan.
Hello everyone, thanks for coming. We are Digital together with Reactive Con would like to present you this discount code for Reactive Con tickets. And after the talk, we were waiting for you for beautiful beers and chips. Yeah, thank you.
I guess stage is yours, guys.
Oh, okay.
Can anyone hear?
You're supposed to be ready?
Behind?
Yes.
Good. So let's go.
Hi everybody and welcome, and thank you for missing the Apple keynote and stay here with us instead. This is Components Done Right, and we are going to be speaking during the next hour about some best practices for component-based architectures. So, my name is Kavya Velasco. I am coming from Barcelona, from Spain, and I work for this company site that many of you already know if you're familiar with JavaScript. I'm pretty sure about it. That is my Twitter handle and my GitHub account and my beautiful dog. I am quite known for this project. I have a few open source projects actually, but this was like the most successful. It's called React Toolbox, and it is a material design implementation in React. It became quite popular, and it's been used by companies like Netflix and Amazon to build internal tools. And this is Robin. Robin, can we switch?
Yes, we can. This is going to be super messy, actually.
So yeah, my name is Robin Frischmann. I'm a front-end engineer from Karlsruhe in Germany, and I work for this company called the Amtrager Remarkt, which you might know in Czech as well. And you also have my Twitter handle and my GitHub handle if you want to follow me. And in general, I'm using React like 4 years now, focusing especially on component architecture and functional UI. And also I do a lot of stuff with CSS. Lately I did a lot of stuff with CSS and JS actually. And there's like this probably my most popular project on GitHub, which is Fila, which is a functional CSS and JS library. But I also do like a lot of other stuff in the CSS and JS community. Yeah.
All right, so to begin with this, I want to make like a very little poll. How many of you are familiar with React? Raise your hand. Most people are familiar with React. More than 2 years experience with React? Okay, half. So many of you are not going to find this talk very interesting, and this is like a small disclaimer. We are going to be discussing some things that are actually quite simple for people that are advanced in React, but feel free to approach us later to discuss more complex topics if you want to. So that is like the first thing I wanted to mention. Second thing is that we have here a T-shirt. I'm pretty sure it is an L, and I have here a knife. So later you can fight, and the last man standing gets the T-shirt. No, I'm joking. I have a gun actually. And and yeah, at first it's going to be very basic. Later it's going to get more interesting. I hope so. And if you have questions, please ask later or use the Slido. And yeah, we are going to share these slides later, so you don't need to write anything down if you're interested on it. And yeah, just relax and listen, and let's move on. So we are going to be speaking about components. So the first question, obviously, is what is a component? And in computing in general, a component is like a modular piece that can be reused across your software. And in this case, we are going to be speaking about components for your front-end architecture. So if you go to the React website, you will see a definition of what a component is that looks like this. Components lets you split the UI into independent, reusable pieces and think about each piece in isolation. It is super important that all of your components, as we are going to see later, are as pure as possible, as reusable as possible, and all the dependencies should be very, very explicit in order to expose the proper API so they are fully configurable and reusable, because that's the whole purpose of modularizing, right? So in a component system architecture, in practice, the first thing that we have to learn is how to think about making components, for how to split your UI into components. So first of all, if you have an example like this, which is actually something very simple, it would be like a book list, and we are going to be using this example across the presentation. The components that we can identify here very clearly are three, right? So first of all, you have this book list component that is including a scroll, and it's going to receive, if you think about the API that this component might have, it could be like an array of objects that each of those would be like a book, right? Then you have this book list item that would be each of these pieces in green here that will receive just the book with the author, the title, and the star. Sorry, just the book, the author, and the rating. And then you can have this rating component, which would be like receiving a score, let's say from 0 to 5, and it's going to be responsible from making that translation from an integer or a floating point, depending on what we are using, to a certain amount of stars that will show this rating. So looking at this example, you can think of a component as essentially a function that is going to receive some data, some dependencies, and it's going to render some UI. While this is pretty simple and not really interesting, you keep in mind it's just a simple example to clarify what we are talking about later. And there are not really any restrictions on how can you model these components, and that's the whole purpose of the talk, just to give you some tips on how to model these components and think about how to design a proper API based on render props or props themselves and composing children to get components that are fully reusable and customizable. So let's see what makes a good component. And to be honest, we are not in that position where we can say exactly what is a good component. The vision might vary between different people. So we run like a small poll to get to know what people think about what is a good component, what are the principles that can make a component good. And between all the answers, we got this. First of all, a good component should have like a single responsibility. We have to respect the single responsibility principle. So a component should do one thing and do it properly. Also, those components should be accessible. You have to think always about people that are disabled and can't use the computer as you do. They also should be predictable, which is a very important principle in my opinion, in order to make it testable, in order to know what you are going to get when you're injecting some dependencies. They should be customizable And this customization is going to be in order to get components that are really reusable, which is the most important part in my opinion. If we are thinking about component system just to have like a modular application where we can reuse pieces, obviously that is the most important bullet point. So we are going to go through each of these points in this talk and discussing them. The first two are a little bit less interesting, so we are going to be very fast speaking about it. So first of all, single responsibility. Robin is going to introduce you this topic. So Robin, and again. There you go.
Right. Okay. So talking about the single responsibility principle, we first may ask ourselves, why is it even important to have the single responsibility principle in terms of components? And first of all, if you just think about it, I think it's pretty logical that it's better to have components that have a single responsibility, because if you look at them, you immediately know what they're about to do, and you don't have to check all the code because you're not certain what some side effects might be. But in general, I think the way more interesting reason is to avoid so-called God components. And this is a pretty common problem when people start learning React, that they kind of put all their code in one single component, which is kind of the same as God classes or God objects, which you might know from other languages like Java. And it's basically saying that a God object, for example, is like a huge object that handles all the state and all the data, and it's like the single source of truth. And in terms of components, this might be, for example, an app component that basically renders your whole application, you know. And the problem with this is that it's a really big component, maybe 3,000 lines of code, and nobody is really confident about touching it because it's changed a lot over time, and yeah, you basically don't know what it's doing and what the dependencies are. But the good thing is, speaking about component-based architectures, that we already kind of have a really powerful tool to avoid those so-called God components. And to kind of explain how this works, I'd first like to talk about separation of concerns first. And this is, especially in component land, a pretty controversial topic nowadays. So let's first look at I would call it classic definition. So in the past, we always learned to strictly separate our HTML, CSS, and JavaScript into single files because, you know, it's important to have separation of concerns. And if we look at this example, thinking about the single responsibility, it makes kind of a lot of sense because in the CSS files, you have all your styling. In the HTML files, you have all your markup. And in the JavaScript files, you have all this logic applied. But if you think about this like the graph, is it actually a separation of concerns, or is it rather, yeah? Maybe who of you thinks this is a separation of concerns? No one?
Nobody? Nobody thinks that this is a separation of concerns.
One, yeah.
One, only one. How many of you think that this is a separation of technologies? I expect everyone to raise their hand. It's either one thing or another.
It's just the point of view.
Yeah.
It's your point of view.
Yeah, of course, that's why we are asking. That's why we are asking.
Yeah, so speaking about this topic, you might already have heard about this kind of newer definition, which is the component-oriented version of separation of concerns. And actually, it's just about, instead of putting all your stuff into different languages, you rather focus on the concerns in terms of components. So for example, this loading component has some markup and styling, and the book list item as well. And sometimes you also have components with logic that kind of have all three of them. And now if we look at this new kind of type of separation of concerns, in terms of the single responsibility principle, we can actually see that in terms of small components, like the first ones, the loading and the book list item, The responsibility is pretty simple because for example, the loading component is just all about rendering like a loading spinner, and all you need to do that is some markup and some styles to make it look right. But now if we look at this rating component, for example, you actually see that the rating component has kind of two responsibilities. The first one is to render those stars, so it's the HTML and the CSS again. But this time, this component also has this logic to fetch the ratings from some API and to handle this data. So it's basically got like two different responsibilities. And as this is a pretty common problem in React land, there has been a lot of discussion actually in the community. And I think already back in 2015, Dan Abramov, who now works for Facebook as a React core member, described an approach to kind of fix this issue and to split the rating component into two different components, both having only one responsibility. And it's the concept of presentational and logical components. And yeah, I would just briefly tell you what they're all about. So on the left side, we have the presentational components, and they are all concerned about how things look. So they contain the markup and the styling, like the loading component, for example. And yeah, knowing this, they should always be like stateless because they don't know anything about the logic, but they receive all the data and what they need to actually render stuff via props from upper components. And in many cases, they also just render children, so they are like fully dynamic in what they actually render, so they just add some additional markup and styling to something. And basically all presentational components should have no dependencies, which means you can take that component from one point, copy it to another point, and it should just work as expected there. Yeah, and some simple examples for presentational components are this loading component, for example, or in general, like all components that are concerned with your style guide, for example, like a button, an avatar component, or yeah. And then on the other hand, we have those logical components that are all concerned about how things work. So they know all the logic, all the API calls and whatever. And yeah, this makes them stateful all the time. And now instead of rendering actual markup and styling, they rely on those presentational components again to actually render all this data they are fetching and handling. So this is kind of the moment where you split those two responsibilities. And knowing this, they sometimes, not always, but sometimes they also have like dependencies because you might have to pass the server URL, for example, which means you can probably not use them from copy them from one place and use them at another place like you do. And yeah, in our example, the logical component would be, for example, the book list component we've seen before, because the book list is actually doing this data fetching from the server and passing it to those book list items. Yeah, and to kind of show you the real code of this example, we will just quickly go through this book list application we've seen before. Yeah. Oh, my battery is almost out. Okay, so to just quickly go through the code, first of all, we have this book list component here that has some default state, and there's this fetch data function that actually just fetch some JSON data from our local page because that's simpler to like show you. And as soon as it's done, we update our state to like have the books. And all of this is done in the component mount. So at the first render, you actually don't have those books yet. And yeah, in the render function, we actually render some wrapping div. And then inside this div, we basically have this part that does all the logic. So first of all, if the loading is still running, we render some kind of loading spinner here. And as soon as the loading is done, we take all those books and map on them and just render a book list item for all of them. So if we, if we then look at the book list item, this is like the common example for a presentational component, because it gets all its data it needs to render something passed down via props, and it then just renders some stupid layout components and markups and renders all this data inside. And then we have another example, which is this rating component, which again is like a logical component, because in our case we are fetching all the ratings from a different API. And it's pretty much like the book list component. We're also doing like this loading spinner, and we have some error state. And as soon as we're ready, we're going to map over this rendering and just render some yellow stars, kind of. So yeah. Now if we look at this example, this is a pretty good use case where we can split those two responsibilities into like two components. And we can, for example, do like the stars components for now, which gets the rating passed.
Of course, this first implementation is not the best that we can do. It's not configurable at all. It's not customizable. You can barely do anything to customize that stars component from outside. So later we are going to be refactoring and telling you why and in which levels can we make that more reusable. You have to
Yeah. All right. Okay, and maybe if you already kind of saw that we have two different loading spinners on our page. So we can also use this loading spinner and do another another component out of it. So all right, and we can also reuse it in our rating component, of course. Yep. Yeah. So yeah, I mean, this is just like a super simple example, but that's in general how you split those two responsibilities into presentational and logical components. And if you do this, it already really helps to avoid those God components, because you can kind of split all your concerns into this component like syncing.
Especially at first when you are starting with React and stuff, you think like it's not okay to have a component that renders just to one element. I think that's completely wrong. In case you have like a button or a link or whatever, it's perfectly fine to have wrappers. So you decide how long do you want to move your customization and your custom components in your UI. I think I put this in the other way, so what the fuck? I don't know how this works anymore. Jesus. Okay, so keep going. Okay. Yep. So accessibility, this is going to be super fast actually. First of all, you have to think why it's important accessibility, and this is a question very simple to ask, which is because you are not more important than a person that can see the screen, actually, right? So to increase accessibility in general, the first rule that you have to keep in mind is to have a semantic markup. The mere fact that we are now writing React components and we are having our JSX instead of raw HTML makes us think that it's very easy to add just divs without any meaning or whatever. And when we are splitting all of these components, we sometimes lose context about what is the purpose of the markup that is going to be rendered in the end. So we are very tempted sometimes to have many divs that have no meaning at all. So first of all, using a correct semantic markup is super important, and you have to think always about what we were told when HTML5 came out some years ago. Like if you have, for example, some components to render a blog post or something like that, it is not the same thing to have just like a bunch of divs where you have to read the actual content to know what is the meaning of that markup than having section, comments, or timestamps, or whatever tags. Also, it's going to be super important to have area attributes. There is a whole spec which is super complex to bring some extra attributes to your to the HTML that is going to be rendered in the end, so you can make easier to understand what's going on for blind people, since the screen reader can give more context on what is the purpose of each tag. Also, you have accessibility audits and dev tools to make your site and your components completely accessible, and you are gaining also some extra features, let's call it like that, when you are having like really accessible components. Like for example, you are going to increase readability a lot, because again, it's not the same thing to see like a bunch of divs without meaning or purpose than reading a proper structured HTML. And that's going to lead you to more maintainable components and more maintainable code in general. And in the same way that a screen reader can understand better what is going on when you have a proper markup, it happens the same thing to scrubbers that are going to get your website and index it, so later it can be it can have like a better positioning when you Google, when you search that in a search engine. So it's very important too for SEO. So that's all actually about accessibility. There is not much more to say about it, only that we tend to completely skip thinking about this. We don't even think about making the website navigable using tabs and space bars and stuff. And only model your components so you can go with the mouse and click and interact visually with them, because it's the common scenario. But we have to be aware of that, and we have to mention that in this talk as well. So now, predictability. I'm getting it back to you. To go. Oh my God. Once again. There you go.
Okay, so now that the first like two aspects have been more like, I think, pretty simple actually. In our opinion, the next three ones are the actual exciting points of doing like good components. And the first one is predictability. So thinking about predictability, we again may ask the question, why is predictability important? And actually it turns out that having predictable components comes with a lot of different benefits, but for us the most important one is the confidence and correctness. Because if you have a predictable component, you are able to predict the output of your component given a set of properties over the time. So you can kind of assure the correctness like over the whole lifetime of your application. And the cool thing is we can use those components and write unit tests that like exactly test if the component still does the same. And as soon as we somehow change the component, for example, we get a notification that the component changed. And this is like, it seems super simple and super like not important, but especially in bigger applications, and if you're working in projects that have a lot of developers and a lot of users, this gets like more important than ever. And also a cool point about predictability is that we can kind of automate this whole the whole part of testing our components using tools like Jenkins or Travis. So we basically get this confidence and correctness for free after every commit we do. But the important question is, how do we actually increase the predictability of our components? And to understand that, we first have to check the definition of a component again. So we earlier told you that a component basically is a function of state, which in our case is thinking about the presentational and logical separation. The presentational components mostly are a function of properties that are passed down from logical components. And that's all. And there's the cool thing we can learn from functional programming, which we can apply to exactly those functions to actually achieve this predictability. And it's called pure functions. And in general, a pure function is just a basic JavaScript function, but with some special characteristics. So a pure function should, given the same input, always return the same output, which is what I just told you before. And it should not mutate its arguments, because then if you call the same function with the same parameters like twice, you get a different output because you mutated the arguments, obviously. And it should also not call any non-pure functions like dateNow or mathRandom, because they might always return a different output, of course. And then they should also not perform any side effects, for example, API calls, because you can never assure that the response from the API is always the same. To have a very quick example of like pure functions and non-pure functions, we have this add function, which just takes two numbers and returns the sum, obviously. On the left hand, we got the pure version, and on the right hand, we got the non-pure version, because before it returns the sum, it first mutates its arguments. And if you call this add function again with the same A, the result won't be the same. But the cool thing is, speaking about React components especially, is that we have a lot of pure components in that case already, because all our functional components, like the presentational components, basically are pure by definition. So looking at this header component, it just renders some top-level heading text given some text that is passed to the component. Well, this is pretty simple. It's super powerful because we can now use this header component, have some unit tests, and like test the correctness of this component. And as soon as no one ever changes the code, we have the confidence that it's going to render the correct output. But now I have I think a kind of interesting example. It's another component, but it's basically the same. We have this view component that returns some div with a given class name, and it renders some text. In this case, it's even static text, so it should be even more pure, right? But now let me ask you, who of you thinks that this component or this function in general is a pure function? Yeah, kind of some, not all, okay.
Want to point something out before he goes on, which is basically that the function, we are not speaking just about the function itself. When we are making components, we are thinking about the whole components. The whole component is CSS, means styling, markup, and behavior all together. So in this case, if we are trying to model a component, which is composed by those three technologies in the end, what we want to make pure is the component itself, not only the markup. So if I ask you again if this is, from the perspective of a component, a pure component, I would say no. And you're not saying, see why we think like that right now.
Okay, so first of all, if we're only looking at the JavaScript part, so the component itself, Technically, it's a pure function actually, because if we take it and write a unit test like we did before, we always get the same output, which is a div with a class name and some text. But now, if we, for example, think about this component like matters over time, and some other developer adds like a condition to color the text red instead of green, we just add this equation and we get another class name, right? And now if we take the component again and write a unit test, we can have like 2 unit tests. First of all, we pass no error and we get the same result than before. And on the other hand, we can pass like the state error and we get this text failure class name in return. So it's pretty much like the same as before. But now comes the interesting one, which actually happens quite a lot in production in general. And I can only speak for myself, but I work on an application with 8 different teams with like 100 developers. And it's pretty common that you change some styling, for example, at some point, and you destroy something completely different in a complete other part of your application. And I'm pretty sure like every one of you at least once experienced that. Yeah, so let's pretend we're another team and we also use this view component, which is pretty cool because it's just red and green. But now at some point we want to render like a big error text. And we go on, we see, oh, it's text failure, it's fine. And we have this font size 20 pixels here. And now what happens is the actual interesting part, because if we take this component now and we render it in a unit test, we still got the same result as before, which is technically like a pure function, and we can ensure the correctness of the component. But if we render this whole component in the browser, it's different. But our unit test didn't catch it. And that's because instead of actually testing the style properties that are applied to the component, we only test like the class name, which is a link to the style properties, but not the style properties actually. And that's like the whole reason why this confusion happens a lot, because we're not able to really test this kind of components here. But there is a solution to handle this issue. It's actually CSS and JS. I know this is a super controversial topic, and I'm not sure how many of you like CSS and JS.
Well, I guess the rest of you dislike CSS and JS, right?
Yeah, I mean it's.
No CSS like this is keynote, right?
Okay.
Yeah.
Yeah, so if you like it or not, let me at least show you how CSS and JS can fix this particular problem. And to understand that, we have to go one step back and add another definition. So first, before we learned that our user interface is just a function of state, right? And React is kind of the markup part of this function. So React is like the pure version of our markup, but still we're using this CSS class names to link to the styling. And a common pattern in CSS and JS community is to define style as a function of state as well, which, if you think about it, might seem like logical. And to show you how this actually looks like, I brought this super simple example here, where the create component is just a small helper that actually creates a React component that then renders a div with the given style class name applied. And it also handles the CSS generation, so you don't have to pass the class name directly, but you rather write your style as a function of state, as we said before. Yeah, and if we look at the style, it's super simple. We have the color again, and now if the state is error, we set the color to red, and if it's not there, we set the color to green. And if we now render this component, we get like two different versions. The first is without the error, and we get the class name A or something different. It's just a generated name. And if we add the error class, the error property, we get this class B. And the library, and in general all the CSS and JS libraries, will render the CSS for you. And in this case, the class A would be the green color, and the class B would be the red color.
So I also think that it is important here to point out that the problem is the class name itself. Like we were saying at first that there's a separation of technologies, not a separation of concerns. And I think that is manifested by the fact that we have to link our HTML, JavaScript, and CSS using those terrible class names. With React, we implicitly move our HTML generation to the component directly, so we are not writing HTML anymore, we are generating HTML. So that we can pass things like, for example, event listeners directly to that HTML that is going to be rendered. But we don't handle how that event listener is actually attached to the output download. That's handled by React. And it is actually the same thing when you think about CSS, with the only difference that it wasn't implemented directly in React. Because we still have to think, what is the combination of class names that is going to give me this specific styling that I want when I have this state? Well, what you want to do is to say, this is the style that I want when I have this state. So this is actually quite more expressive. And the huge benefit is that the correspondence between the CSS that is generated in the end and the class names that are being attached to the HTML are generated automatically by the library. So we don't have to think about that link anymore. And this has even more benefits because under the covers, it can reduce dramatically the amount of CSS that is generated in the end. So this is solving definitely this problem, and it's giving you even more benefits.
Yeah, because I think one very practical kind of result of doing this all together is that you are able to kind of automate your layout tests via snapshot testing. And we have had a lot of problems with layout tests at my company because it's a huge application. It's a whole online shop for DM actually, and it's quite a big project with a lot of legacy code, and we have like tons of layout tests written in Galen, Selenium, you name it. And the problem is that we always, like every 2 weeks when we do a new release, we have tons of layout tests failing because obviously we changed some layout, which actually is what we wanted to do. But then we have to go there manually fix the layout tests because they are not like smart at all. And now doing this CSS and JS pattern, we can improve our predictability up to that point that we can fully automate this process. I have a pretty small example here. I actually wanted to show you real code, but I kind of messed up with my node modules and it's not building anymore. But if you're interested, we will put that example into the repository afterwards, hopefully if it works, but maybe tomorrow or on Friday it will. Yeah, so if we look at the first thing is what we actually test. So we use the testing utilities React gives us and just render those two different ways of our component. And instead of just generating the snapshot of that markup, we also use a function that probably, I guess, every one of those 100 CSS and JS libraries exports, which is a function that helps you to extract the static CSS into a string, which was generated by just those two components. So in the end, our snapshot contains both the class names and the CSS in general and the markup, which is kind of testing, not only testing like if the correct class name is applied, but we are actually testing which style properties are applied. And now as soon as someone changes some of your code, your snapshot will actually break even if the markup is the same because the styling is different, of course. Yeah, so yeah, that's basically like the the full way of doing your components, getting your components more predictable. And now we want to talk about customizability.
All right, so customization. Why do we want to customize our components? Obviously, because we want to reuse our components and we don't want to write the same thing again and again and again. I'm not sure how many drop-downs have you wrote in your whole developer life, but I did quite a few. And time pickers, and overlays, and models, and components are always the same behavior, same JavaScript code that I have to cope from one component to another, and then I want to change, for example, the color, the size, the rendering pattern, and I have to rewrite it again. So that's why I want to customize components. So if you think about this example that we had before, we extracted that rating component that we had in two components. One was the rating, which is going to be responsible from fetching the actual rate, and only that. It's not going to render any, well, it's going to render directly that other component stars. We did that wrong on purpose, and the responsibility of that component was just to get one value and translate that value to an amount of stars. So let's say that we want to make that component customizable. So how do you customize that component? What is cool about React is it's that a component is just a function, right? And the dependencies of a function are the arguments that you're passing. And as long as your function is pure and is predictable, you can make sure what is going to be the output from a given input. So the only API that you have to customize a function is to provide some props, some properties, to define an API that is going to tell from that props how it's going to be the component rendered in the end. So in that stars example, you are getting a value. But let's say for a second that we want to make the stars bigger. The only property that we were accepting was the value. And also there is no children, no anything. It's automatically rendered by the rating component. So one solution would be to write CSS, global CSS with that important, but we don't have that in CSS and JS. So let's say we add a property size, right? So boom, you got it. You give it a default prop, which is going to be 10, for example, and then when you pass 15, you get bigger stars. Cool, but now if you want to change, for example, the color, you add another property, okay? And then if you say, I want to change how these stars are rendered, and I want to add, like, for example, a legend to that rating, suddenly you think, okay, so I can add another property, which is going to be a Boolean, that is going to be show value. If show value is truthy, I'm going to render that, otherwise I'm not rendering that. The problem with this is that we are designing an API, yes, but it's configuration. We are saying how to configure your component to provide some customization. And the problem with that is that as the component grows in complexity, you have to predict what's going to be the customization pattern. So at first you might think, okay, probably the stars are going to be customizable in size. So you add that property, size. And then maybe you think that the color is going to be changed as well, so you can add it. But in the future, if you decide to change the number of stars, or maybe the pattern between the number that you're passing and the number of stars that are going to be rendered, maybe that's not something that is predictable at the beginning, so you are not going to decide a configuration for that. And that's why this is not the best way to do that. It's way better to try to embrace composition over configuration. And the way to do that is to always try to design your components to accept children as much as possible. And maybe even cloning children and injecting new properties when it's needed. So apart from that, we are going to give you some advice on how can you master those props, or what can be done and what shouldn't be done about props. And the first thing is to avoid those multiple Boolean props. The first code smell when you are adding Boolean props is what I just said, that you are adding configuration, and most likely configuration about the rendering, to decide how the component is going to look like depending on those properties. And usually it is way better to just use children when it's possible. If you can't use children, there is a pattern that Robin is going to tell you later, and probably you are aware of that, some of you. But also you have to avoid multiple Boolean props, because imagine that you have a button that by default looks like that. It looks great. And then you say, okay, I'm going to make a primary button that is going to look blue. So then you add this primary property, which is a Boolean, and if it's truthy, it's going to be blue, and otherwise it's going to be with the default, right? But then you add a secondary, and then you add a secondary property, and you make the component look red in case the secondary property is truthy, and otherwise you make it look as a regular button. But then what happens if you pass primary and secondary? You are losing predictability here. You can maybe design explicitly what's going to happen in this scenario. But the problem is that those properties are mutually exclusive. So you have to think when you're designing your properties, what properties are the mutually exclusive. And in this case, it's way better to just have a property like variant or level or whatever that can take a certain amount of values, an enumeration of values, so that you can use that instead of passing those Boolean properties. I probably agree with you that the first one is cleaner, but the second one is more correct, in my opinion. Also, you'd want to spread props in general. There are many places where it makes sense to spread props, like for example, when you have a component that is rendering just one element and you don't want to explicitly enumerate every property that that element can take. The properties that an element can take are already, you already can tell by just checking the React documentation, or just because you know, being that whatever tag, what properties can take. But usually if you have like a huge tree and you are super used to spread properties across your components, you might find yourself in a situation where you are passing a property that is being outputting an element and it doesn't belong to that element. And if you do that over a lot of layers in a huge component tree, you try to figure out where that property is coming from. It's actually quite difficult. Also, React is going to use all of those properties when it's calculating the life cycle and the updates. So it's better to be explicit on what properties are you passing down, also for the sake of readability and maintainability as well. Like you see, for example, this button and you are just spreading props and you don't have a clue what are the properties that the button can receive. Because first of all, you don't know what's coming from upside, and also you have to browse the button and check what are the props. And if you're lucky, you'd be using prop types, which is something super important. And if any of you thinks that using TypeScript or Flow can make you get rid of prop types, I disagree, because it works in a completely different environment. And let me make this clear. Imagine that you have your application completely typed with Flow, and you are consuming an API. And that API is returning some kind of object that you have properly typed in a schema. But then your schema is wrong. And you have a property that is supposed to be a Boolean and it's supposed to be always there. But you get the whole payload and without validating it or anything, you inject that into a component. When you do that, your component, if the component properties are properly typed, it's not going to fail and the whole application is going to work and it's going to compile, transpile and everything. It's going to be fine. Because the properties are the same types as the schema that you are running. But then when you run that in development, for example, and you have prop types, you realize that you are fetching that data in the API, you get the whole object, and then you pass that to the component, and then it turns out that the schema was wrong. Well, if you are using prop types, the component is going to tell you directly that whatever property is required or it has an invalid type or whatever, and then you realize that the schema that you defined for your API was wrong. So it's super important actually to use prop types, and I encourage you to use them always. Also, you should try always to provide useful defaults for your components. This is very obvious. And the most important thing is to try to keep your components as simple as possible. meaning that don't have like a lot of properties for a component, don't make a God component. An example of this problem is, you can find an example of this if you go to this project. It's called a React table in GitHub, and you check the documentation of that project. You will see that there is a component that has like, I don't know, 100 properties. Yeah, I mean, imagine the combination of that. 2 power 100 combinations. It's fucking crazy, right? So when you are going in that direction, like having a lot of properties, probably you're doing something wrong in a sense that you can compose multiple small components. And maybe if you need to pass information from top below, you can either read those childs and inject new properties, or use the render prop pattern that Robin is going to speak to you about in a second, with reusability, which is the last point and probably the most important, I think, or the most valuable.
All right, so just as Javi said already, reusability, in our opinion, is maybe the most important part of components. And looking at our poll, which we showed before, it was like rated the highest. So in general, what we are trying to achieve with components is to be able to reuse them. And the funny thing is, if we read something about React, it's always mentioned. There's like tons of buzzwords, but reusability is kind of there always. And all the people speak about reusing components and whatever. And while this might be true theoretically, actually, when I'm looking at my company, for example, and I think probably a lot of you experience this kind of problem as well, is that we have some components we are sharing with all our teams, but it's really, really hard to actually reuse those all the time, because every team has some kind of custom requirements for the components, and in the end we turn out to add new props that are kind of hacks to add something else, and we make our components more complex and complex just to reuse them like at every point. Yeah, and often a lot of developers just are like annoyed of that, and they copy the whole code, paste it in their own like project, and yeah, you gain nothing of those components in general. And to speak about how we actually can reuse components, I would first like to briefly talk about how we can reuse presentational components, because we learned like the best ways already. But then I will focus on how we can reuse logical components, because this, in my opinion, is the interesting one. But so first, speaking about presentational components, we already learned that customization via props is a really powerful way to reuse your components, because if you try to keep your components small and focus on composing a lot, you have like a lot of small components that are really like, I would call them dumb, and they only got some properties, but you can do a lot with them because you can compose all those components. And especially if you're having, for example, a style guide with buttons or whatever, you have a defined set of buttons. And in order to make your application like clean and looking the same everywhere, you probably reuse those components a lot without some extra hacks and special configuration. And another cool tool to customize your components on a higher level is the concept of theming. I think most of you are kind of familiar with theming already, but the whole point about theming is that you have, for example, if you have an application that is in light theme, and now you want to add a dark theme because everyone is adding dark themes nowadays. And the problem is, if you want to achieve that, you would have to go to every component and like switch the color from light to dark. But it turns out that you can just use the concept of theming, which basically gives you an object of like properties, for example, primary color, secondary color, base font size, and all those like style system properties. And then you can use them and just switch those properties over. And if all your components consume that theme, they will automatically adapt to the theme value. So you have you have to switch like maybe 10 properties, and there you go, you have kind of a dock theme. And there's one additional advice I'd like to give you for presentational components, which I ran into a lot. And it's basically about moving the layout flow of your components, especially the alignment of the components, but also like the margin and the spacings and everything up to the parent component. Because, for example, if you have 3 buttons with a spacing of like 10 pixels in between, and now you want to use and the button defines that spacing with margin right 10 pixels, and now you want to reuse that on mobile, but with a spacing of 15 pixels, for example, you would have to reintroduce another prop to your button component. And basically you would be doing this to all your presentational components at some point, which is kind of not the point of that at all. But it's way simpler to just set the alignment and the spacings and whatever in the parent component, because then you're at the exact point where you basically know what your component should look like, and you're in the right context to tell them how to where and how to render. And yeah, it might look kind of ugly if you look at code with a lot of spacing components or whatever, but in my opinion, it turns out to be way more simple and way more straightforward after all. And yeah, finally, I want to talk about how we can reuse logical components. And to use the example we had before, we are using this rating component again, which we know it calls the API to get this rating data from our backend. And it handles the error state, it renders some loading as long as the request is not done yet. And as soon as it's done, it renders some HTML elements. Or if we're applying this presentation and logical concept, it renders some presentational components. But in the end, it actually renders some HTML to our website. The problem with this is if we want to reuse this rating component, and let's say we want, for example, instead of a spinner, we want to modify this loading part of our component to have the spinner with some text, for example, we would basically have to either reintroduce some props to this rating component, which is not what you want to do because it's a logical component after all, or you would have to copy that component again with another loading spinner. And while this seems like pretty simple, think about the next example. You are also building a mobile application with React Native, and you want to reuse that rating component in React Native as well, but it turns out you can't do that because React Native doesn't know HTML at all, and you would have to do all of this stuff but with native elements, which using configuration is basically impossible because you could have tons of components in there. And copying the component is again not what we want to do when we are reusing components.
So to me, the complicated thing here, or what you have to notice, is that when I was speaking before, I told you that in general we can make components composable just by embracing children. But the problem is that when you are using children, you don't have like an explicit way to pass down information in case that the parent component has some information, and this is the case. We refactored this rating component before in 2 different components, and in the render function we were rendering the stars, right? So the component rating is deciding what's going to be rendered, while its responsibility is not rendering anything but fetching some data and then passing it down. So that is the problem, that we are mixing 2 responsibilities into the rating components, and we are doing that because of the lack of an explicit way to say to expose what do you want to render. And this is especially true in the React Native case, as Robin said before. Because if you want to render something that is native, you don't even know what kind of output that component is going to render, but you know that it's fetching or it's doing some kind of behavior and handling some data that is going to be used under the covers. And the way you can get to a solution for this is using headless components.
Yeah, actually headless components in general is a pretty much new concept in React world, which is emerging like super fast right now. And it's all about using the render props pattern. Who of you actually knows about the render props pattern? Yeah, at least not all. Great. So you will hopefully learn something here. And to speak about headless components, it's just a basic React component again, but like the pure function, it has some characteristics that are special. First of all, obviously, it encapsulates some logic, which is the data fetching and handling the state and all this stuff. But then it doesn't directly render any UI. So basically, it's a user interface component without a user interface. And the cool thing about the headless components is that they are actually platform agnostic. So you can use them in React, React Native, React PDF, React SketchUp, React, you name it. And the pattern of headless components is all about using a render prop, which is actually, if you think about it, it's pretty simple. Instead of directly rendering some markup, you call a function that is passed to this component from the outside, and you call this function with all your relevant data. So in our case, it's the rating, the actual rating value, it's the is loading state, and it's the error state. And to see how this works, I'm now going to quickly refactor that rating component we've seen before to use the render props pattern. Oh, my battery is completely empty. Can you give me my charger?
Oh, no way.
Maybe,
Yeah, just come on, play with it.
give me the mouse. Yeah. All right, so I only got 9% of batteries left. I hope it will.
9 is that's enough.
Okay, so first of all, looking at this rating component here, we have to get rid of all this actual rendering, but instead we have to return the result of our render function. And to do that, we call the children property. It's kind of the common pattern to use the children property to pass down the render function. But in general, you can use any property name you want to. And we pass all the relevant data to our component here. And just remove all this stuff here. And now, as you can see, there's no actual markup in here anymore. And if we're going to the book list item for a second, and we see that render component, that rating component here, we can actually now pass the children down. And we get all our data we described before. That we got the rating, the is loading, and the error. And we return if this loading is true. For example, we return our loading component. And we go on and we just return the stars component as soon as our rating is actually fetched. Okay, it looks a bit different because we now use the flexbox column instead of the row, but we could actually fix that later. But in general, I think it's pretty obvious how the pattern works. So instead of having all this rendering logic in the actual rating component, we move it up to the component that consumes that logical component and give all the power to render something to that actual component that uses it. And the great benefit of this is, especially if you're having a lot of backend services, for example. And to give you an example, I have in my team I'm working for the account user account part of the application, and we got a lot of REST services like create user, change address, create address, whatever. And instead of like exposing this REST API to all the other teams, because obviously they all need to use those APIs, we now provide an NPM package which has a lot of those render props logical components, encapsulating all this data using our API. So they can just import, for example, user address, and they get all the addresses. They can call like change address and whatever with all the data, and they don't have to think about how the REST call is done and anything ever again. So this is a super powerful way to kind of pass our complete application logic over to React components that other teams can use. And yeah, that's basically all it is about.
There is only one more thing that I want to say, which is that this is actually pretty obvious. I mean, when you want to, if you have some data and you know what to do with that data, the API that you provide is nothing. It's just doing whatever you have to do. But as soon as you want to invert the responsibility, which is this case, because you want to invert the responsibility of the rendering function, what you do is just to accept a function, which is what is going to give you that ability, right? You can use children or you can use anything else. And there is something that I want to point, which is that in this case, we wrote the function declaration directly in the render function. There are many people that say that that might impact performance. If you think about that, every time that you are calling the rendering function, you are going to create a new function again and again and again and again. In some cases, that can lead to performance issues, but your application has to be super big and you have to repeat this pattern a lot to get to experience that actual problem. So, in my opinion, you can just start by declaring the functions, and then if you get into some performance issues, the way to avoid that is to use class components. And then the rendering function, instead of being declared directly in there, you can just define a member function in your class. So that we were told before, like embrace always functional components is okay, but if as soon as you need to declare a function inside of the component, it might not be that good idea. So yeah, that's pretty much it. So in summary, you have to respect always the single responsibility principle in your components. Try to have components that do only one thing, and as soon as you have a component that does multiple things, probably you can split it and make it some components that are composable to get to where you want to go. And then your components should be as accessible as possible in terms of semantic markups and tooling, or using ARIA attributes, etc. You have to make your component predictable so that it's easier to test them and you know what to expect from each component always. And if you can use CSS in JS, I think that is something good and something that we can discuss later if somebody disagrees, which I think that many of you. And you can make always your component customizable. Follow those principles that we said about props. Try to embrace always children, and think about what is the responsibility of each component in terms of inverting responsibility, so that you can get really reusable components. I think that's very much it. We did a bit more than an hour, so thank you so much for listening. Thank you so much for being here. You can ask now any questions. No? We are not doing questions? Oh, we have the questions already. Okay, that's perfect. Yeah, so let's go with that. Do we know who asked the question? You should probably know, because we are going to give away the t-shirt to whoever that asked the question. Yeah. Who did this? Yeah.
Most interesting question.
Okay. You start if you want with the snapshot testing.
Yeah. Okay. So we now got our questions in Slido, and I will just start with the upper one. Actually, the question is: Do you think we need snapshots if already exists tools like Cypress? To be honest, I've never actually tried out Cypress by now, but there is another team at my company evaluating Cypress, and as far as I can tell, they are pretty happy with it, because it fixes a lot of problems that Selenium had way before. But I'm not sure if it's, I mean, I don't know the tool actually, but I think you still have to do some kind of manual stuff to set up your layout tests, and they will not adapt if you change something, but correct me if I'm wrong at this one. Yeah, but it probably might replace snapshot tests, but I still think snapshot tests is like a super easy way to quickly test your layout. Yeah, and if any of the questions are not really like answered afterwards, just come to us and ask us.
What are your thoughts about HLCs and libraries they recompose for customization? Well, I think that.
Oh, yeah. Anyway, I think we fucked this up earlier. So, yeah, I think that higher order components are quite okay, but I have a personal experience with recompose, which is that once you get what's happening with when you are using recompose and how do you compose all of these higher order components into a super components that inject a lot of properties and spread those properties down, is that you can look at that and it's like an amazing picture. Like you see that, oh, look how beautiful is this, how split it is, how I can reuse this higher order component to inject the stuff. But then you go and leak that code to anybody else, and especially if it's not familiar with functional programming, it's like, what the fuck is this? I mean, it's not explicit. What are the properties that are being injected and passed down? So that, to me, seems like a problem in general. If you are using a type system, like if you're using TypeScript or Flow or something like that, and you are capable of writing types for all of those functions, and especially to type the composing function, then the output is going to be kind of documented, and you know what properties has the final component. And I think that in that case it's actually quite okay. But it is true also that there are some patterns that can be achieved with higher order components, but it's not possible with render props. I remember that when render props started, the render prop pattern popped out and everyone was discussing about it. I had one specific case that I couldn't resolve using render props, but I could with HLCs. But in general, I think that it is quite okay, because technically it's the perfect way to reuse, because you split into smaller functions and decompose to create bigger functions, and then you decode some components and inject all of that behavior. I think that's super okay, but it's also quite obscure. So if you can use the render props patterns instead, I think it's better, because the dependencies that you are injecting to the component that is being rendered in the end are explicit, and that is a huge benefit, in my opinion. So yeah, you want to add something about that?
No, not really.
Yeah. So CSS in JS, my man.
All right. So first of all, I think we will do like maybe 3 more questions, depending on how long it takes, because the food is already ready, and I probably think you're like hungry and tired already. But if any of the questions still like super important for you and it wasn't answered right now, feel free to approach us later on anyways, and we will try to somehow answer the questions anyways. So, yeah.
Once again.
Okay, so how to reuse styles in CSS and JS to not ruin the pure function approach? Because when you start to export and import styles as JS objects, it creates side effects. I'm not really sure if it actually creates side effects in that term, that it destroys the predictability in our example, because I mean, you can export and import styles, and you can like manage your styles to reuse them and compose them as JavaScript objects, obviously, because in CSS and JS it's just about a JavaScript object. But if you are importing an object from another file, and you're doing this test, for example, and the other file changes, your actual snapshot will fail as well. So it's still like safe to at that point. But I'm open to discuss this later on if you want to.
Okay. No, keep it. Why do most JavaScript developers type imports manually? Because JavaScript is fucked and we are stupid.
Yeah, actually, I tried out a lot of like different auto-completion tools, especially in Visual Code. They're adding a lot of stuff like every week, and I most of the time turn it off because, for example, there was a tool to, I think, automatically generate the imports as soon as you type something, and instead of actually importing the real stuff like import React from React, it always did like import React from /node modules blah blah blah, and I was like, okay, I just type it manually and I will be fine basically. But yeah, you don't have to do that obviously. Next one?
No. Well, are we going to keep answering questions or what?
One more maybe?
Yeah. Was that second function impure? Well, I don't remember the exact code, but if it was in the upper scope, yeah. If it wasn't in the upper scope, of course not. But yeah, I don't know. Check later the code. How do you test components? Are there any differences between presentational and logical components? Yeah, sure. So in general, in my case, for example, when I have to test a presentational component, what I do is just to use render snapshot testing. I think that's the easiest way to do that. Get all the possible combination of prop types. Just another reason not to have bloated prop types.
I can say something about that if you want.
Yeah, of course.
Yeah, I'd like to answer the logical part of that question. Thank you. So I had struggled a lot with testing components with state in general because you have to use some tool, for example, like enzyme to trigger some click or whatever to even get to that changed state in your test. But what I'm doing lately is that I try to extract all these state handling to like outside of the component, for example, with Redux or whatever tool. And I try to do it in this reducer pattern way. So it's the concept borrowed from Elm, I guess, in the first hand, which is basically that you define actions that have the current state given some payload if they want to, and they return the new state. And if you extract your state handling that way, you can then use those actions to actually test them because they have to be pure functions in most libraries. And as long as that part kind of works, I just trust React that they don't fuck up my component state. And up to today, it turned out pretty well, so I did pretty good with that. Yeah.
I just want to point out that the last one there, is it okay to use state components inside function, blah, blah, blah? I think it's what we answered before. Like, it's not going to create like a performance issue at first, but maybe in the future it could, so that the only way to resolve that is to move those functions to the member functions in a class component, rather than using the stateless component directly. If you're using a stateless component or a stateless component, of course that's not even possible.
A t-shirt, no, I guess.
What?
Yeah.
Well, this is more complex to answer actually because it depends a lot on the project. Now,
we should do the t-shirt now. I think it's
oh yeah, the t-shirt.
super late.
That's true. How do we do that? Okay, raise your hand. Questions? Raise your hand. Raise your hand. Higher. I'm gonna do this Spanish random thing. What? Oh, you missed it. I'm sorry. Oh, thank you everyone.